Welcome to using the filter element collector to access elements in Dynamo using Python. So here's a empty Python script. I'm going to use Visual Studio's community to build out my program and publish it to GitHub. I'm going to go ahead and add the Revit node as a reference. So I'll add the reference Revit node and I'll import Revit. I'll go ahead and also get the Revit elements. And the next reference that I'll add is I'll go ahead and get the Revit service, which will be the document, the current document which I'm using from Revit service. I will get Revit service and the persistent document manager, and I'll also get the Revit API. And I'll go ahead and import Autodesk and the Autodesk Revit database, and the star just means that I'll go ahead and import everything. And then I'll import the systems, and from systems collection generic, I'll just go ahead and import everything. So I'm going to get the document from the document manager, which I referenced in the Revit services, and I'll go ahead and get the instance of the current database of the document. And then here is the filter element collector, and this is how you access most of the elements in Revit. And what I'm using here is a quick filter. So what I'm going to do is I'm going to get a filter element collector, which is the shortcut of the class. So here I got a collector, which I'm sending from the filter element collector, sending in the document, or the current document which I'm working on, sending it down into the collector, and then I'm going to use the shortcut of class, and I'm going to get the walls, or the type of walls, and then I'm going to send them to an element, or a collection of elements, which is a list, and then I will send this right out to my Dynamo. So here I'll just go ahead and copy and paste, and then run it, and it'll grab everything that's in the wall category, or in the wall class, and send it right out to the node using my script there. The next thing which I'll do is I'll get the active view, which will be the view in Revit on the left hand side, and what I'll do here is I will rewrite it in a more standard way, which you'll see a lot of code samples written in. So again, I'll get the filter element collector, I will send in the document, and then if you put in a comma, you can put in the document active view ID, and that's the current view that you're selected in. And then this is the part where most of the time you'll see things written in, and you'll, instead of having it sent somewhere else, you'll just see a dot of class, and then I'll get the type of wall, and I'll go ahead and send it to an element, and it'll all be sent right back into that a list here. So what I'll do is I will delete some of this code out that I'm not actually using in the script, take away the portion, go ahead and send my active view, copy the list out to be sent to Dynamo here. I'll refresh it by grabbing a new watch node. I'll go ahead and delete the old watch node, and then go ahead and run it and send the active view, which is the left hand side, which is level 1, and it only has 4 walls. And that's how you get the active view. So the next part here that I'd like to use is the quick filter of category. So if you're looking for a certain category, you can send in the filter element collector, you can get the current document, and instead of class here, you send of category. And here are your built-in categories. So you'll send in the built-in. These are well documented in the document Revit API. They're named a little funny, but if you look it up, you can always find the OST_wall to get all the walls of the category. And we want to get the instance of the element. So where the element is not an element type, we want to get that, and then we'll go ahead and send everything that is an instance to an element back to our list. So we'll just take this long string here of text, and we'll wipe this out and plop it right into remove some of the code. All we need is the document, our references, and copy and paste the out here, and then we'll get a new watch node, and here I'll rerun it. Got a little bit of snippet, look up the number that it's missing, quick debugging on the fly here. It looks like the built-in is a capital B. We'll run it, and there you go. Get all our built-ins. This is going up to the GitHub, so want to make sure the code's right with a capital B. That way, if you copy and paste this in, you won't also get the same error as I did. Okay, so the next part here. So the next part here is I want to use a for loop. And I'll go ahead and generate an empty list, and I'll use for the wall, which will be a W, in my built-in categories, which is the built-in categories list. And I'm searching for something in particular, parameter, could be whatever. If the W name equals SW, which is a shear wall, and 48 inches, then I'll go ahead and just add it to that empty list. This is a wonderful way of looking up anything that you want, any parameter or anything that you can filter. This is a great way, and this is why Python is very helpful compared to doing a lot of other stringing a lot of nodes. You can just write in a simple script like this, and we can get a new watch node here, and then we'll go ahead and send this in and run it. The element IDs in the wall don't really tell us very much about the information here, so what we'll do is we'll just get the name of the family. That way, if it equals 48, you can see that this filtered them out to get just the 48. And so the next part is I want to shorten the amount of code that I've written, and there's a thing called Lambda Expressions, and they're an anonymous function or definition that is not bound to identifier. So it's basically a method or a definition that's written all in one line, or you should try to write it in one line. Once it gets longer than one line, you should just write a method. But here, what we'll do is we'll grab a list of walls, and we'll filter them by the lambda expression, and we'll go ahead and call the lambda x. And our x will be our iterator, so it'll iterate over our list. And so x is now our name, and then if it equals the shear wall 48, which is the same as the W equals, and then we'll go ahead and grab our list here, put a comma, make sure to put that comma, and then we'll drop in our built-in category list. So now here's our iterator, our lambda expression. I'll send it right back to that wall there. So I'll go ahead and copy this into my Dynamo Python script here, and I'll go ahead and delete out that for each loop and write in my lambda, copy and paste it to my out, and run. Here I gotta delete that. Make sure I get a fresh watch node. That way you can see the code actually work. It should generate the exact same thing. Here I get the exact same 4 walls that are 48 inches on the top and the bottom of my tower, 2 floors, and that is the lambda expression. The next thing I want to build will be what is defined as a slow filter. And as far as um, the speed of filtering, I know that right now we're only doing a few walls, but if you filter thousands of things, the lambda and the for each are very slow. The of class and built-in are incredibly fast, making it very efficient. The slower filter is slightly faster than the for each and the lambda expression. They take a lot more time because they iterate over every one of the elements. So here what we'll do is we'll get a couple of built-in parameters, which should be a lot quicker than trying to iterate over multiple ones. But so what we'll do is we'll built in the list of built-in parameters, and then we'll go ahead and add the door and the walls category or built-in categories, and we'll go ahead and send it. That is constructing our filter. So now our filter is looking for the two built-in parameters in our list, um, and it'll be the element multi-category filter, which is a slower filter, but yet very efficient. I think the rule is to use Autodesk's filtering before you use the lambda and for each. It's still limiting, but here this is just an example of one of their slower filters. And then we go into the filter element collector. We send in the document, and the where it passes our filter, we'll go ahead and add it to our element and send it back as an element to our list of elements. So we'll just go ahead and copy and paste this uh, into our uh, script here. And make sure we copy this element, which will be our list, right into the out, and then we'll run it, and we see a list of the walls, the doors that I have in the project. I think my family names kind of got a little bit whacked out, but it's not important because what we're looking for is just kind of a group of categories that we want. And this is nice because every now and then there's a handful of categories that you want. You can organize them, send them out. Anyways, thank you for watching. For more Revit API videos, please subscribe.